All right, all you sequestered mathletes, we are looking at our last chapter for Math 370, or this pre-calculus class. Woohoo! Okay, so we are actually dropping the pre-calculus prefix, and we're going to start doing some calculus. So the pre-calculus is done. Ha ha ha. Now we're going into calculus. All right, so enough of that. So 14.1, we're finding limits using tables and graphs. So let's talk about that for a second. What do we mean by finding a limit? Well, people find limits all the time. Roadways have speed limits, which we often don't follow. Toddlers figure out the limits of their stressed parents, and people push computers to the limit all the time. We're also finding our limit of how long we're going to be quarantined, or yeah, for all this virus stuff. So a limit is a value that something approaches, and in math, that concept is really similar. They analyze a function and they answer the question as x approaches a specific value. So like as you approach a certain value on the road, what happens with the function value? Or the y value. So as x gets closer and closer to something, what does the y value do? Does it also approach a single value, or does it do something different? Does it like shoot off to infinity? Does it keep bouncing around? Or does it kind of approach a number? So there's three major ways to figure this out. Using a table, which we'll see in a moment, using a graph, which we'll also see in this section, and then the third way is using algebra to analyze the function itself. So we're going to look at the first two, and then the next section looks at the algebra way. So let's start with a table. So using a table, you try to surround and close in on a particular or given x value. So this requires us to choose different values for x that are higher and lower than the value in question. Once we've chosen these values, we'll plug them into the function and look at the results. So let's see how it works. So that's kind of a general process. So consider the function f of x equals x to the third minus 8 over x minus 2. What's the one value we can't plug in for x? Well, that would be 2, because that would make it undefined. So what happens to the function around this value? To answer this, we're going to look at the table. So I've surrounded this value of 2 by numbers that are smaller and numbers that are higher. And what I've done is I've come in this way, so I've surrounded it and I've gotten a little bit closer and a little bit closer and a little bit closer every time. And I've taken, so once I chose these numbers for x, I took them and I plugged them into the function to see how it came out. So these are the results for each of these 6 x's. So look at the values of the function, the answers that came out. As x approaches 2, like, do you notice anything? Well, yeah. Well, what do you notice? Well, for x values from the left of 2, or smaller than 2, so over here, f of x, if you look at it, it's coming in closer and closer. These numbers are getting closer and closer to what? 12. It's like you keep adding like in an extra 9. So it's like 11.9994, 11.99994, and so on and so forth. Well, if you look at it from the right, or this other side, as you get closer to x equals 2, these y values look like they're getting closer and closer to 12 as well. So since we approached 12, not sure why I gave you such a big space, but since we approached 12 from both sides, we can say that the limit is 12. right, so that's how the table is going to work. So I'll stop the video here, and in the next one, we'll look at a couple more, and then we'll start looking at graphs.